Next up, we have Justin Hiemstra from the Pelican team talking about authorization in Pelican.
All right. Good afternoon, everybody. I'd like to talk about authorization in Pelican, but before I get started with that, I want to run through a little role-playing scenario. And if you're one of our facilitators or one of our more recently onboarded users, unfortunately, this experience might be familiar to you. So imagine you're a researcher, you're a domain scientist, not one of us, funky computer scientists. And a facilitator comes to you and they say, hey, we just got done setting up your origin. It's plugged into your object store and your data is federated. It's ready to go. Why don't you go ahead and kick the tires, take it for a little test drive and let us know what you think. So you think this is pretty great. All this data I've been hoarding, I can finally unleash the OS pool on it. But the facilitators say, don't get ahead of yourself. There's a little bit of friction here because your data is protected, which means we first need to talk about keys. Okay, you think this makes sense, I guess. My data's protected and there are keys to it, right? Well, it's not quite that simple because these aren't really keys to the origin. They're a different kind of key, okay? They're a key that integrates with this thing we call the issuer. Okay, you think, so what? I take this key to the issuer and I unlock that and that's how I get my data? Well, no, it doesn't quite work like that either. You see, these keys are used to mint tokens. And it's still not as simple as you're thinking it might be because in order to create tokens, you have to understand audiences. There are a handful of other things, profiles, scopes, etc. And to make things worse, if you're the one holding this key, you need to know how all of this works. And if you make any mistakes along the process, we have trouble telling you exactly what didn't work. It's really hard for us to tell you why your token wasn't accepted. So we have this issue at this point, right, where our domain researchers, all they really care about is getting their data. And yet, in building this authorization system for our distributed high throughput computing environments, we've added a lot of friction to the process for our users. Ultimately, all they care about is why can I get my data? So I want to talk about this authorization system, but before I can do that, I want to go into a little bit of detail about what problems we were trying to solve in designing it. And to do that, we need to talk about a few questions first. The first is, again, what problems are we trying to solve? Second, why don't we use something simple like passwords? I mean, we all kind of hate password-based authentication, but it's familiar to people, so why don't we use it? And then finally, what are we doing to make this whole process easier for our users? So I think we can motivate some of these questions by looking first at the types of systems that we're designing, in particular, federations. So if you think back to your high school civics class, I think civics is really important these days. You'll recall that a federation is a system where a group of loosely related but still autonomous entities come together and join their resources. And in doing so, they're able to accomplish bigger things that any of them could accomplish on their own. So this is one of those cases where the whole is greater than the sum of the parts. Now, if you think about the OS pool, this looks like different campuses and institutions joining their computational capacity together. And in doing so, they unleash the power of high throughput computing and do types of science that would otherwise be unfeasible. Now, if we take this concept of federations and we apply it to data, we see that a few things have to be true. First, we need to respect the autonomy of the people who join their data together in these federations. That means that the data owners are able to come and go as they'd like. And importantly, the data owners have ultimate authority and control over how their data is used, distributed, and accessed. So this is the first point, autonomy. The second point is under the category of centralizing your data under some kind of service. By doing this in Pelican, we're able to provide unified namespaces across decentralized storage. And this is good because to our users, working with data through Pelican, everything feels like it's coming from the same source. You don't need to worry about whether the object store is S3 or POSIX, et cetera, et cetera. It just feels like Pelican. And then finally, and really importantly in high throughput computing, is that by doing all of this, we are able to scale better than we would be able to do otherwise. So the topic of authorization, I think, at least in the way that we've done things in Pelican, really deals with some of these first 2 points, which relate to the autonomy and also the scalability, but especially the autonomy of our users, of our origin and data store owners. So I want to be clear about something because to non-computer scientists, these two words usually mean the same thing. But in this context, they have specific meanings. So authentication, as we've learned from Jim Basney and Matthias's talk earlier, authentication means you're proving something about who you are. I'm Justin, and I can prove that because I have an ID in my wallet that says Justin. Marone will tell me these are identifiers. They are not my identity. On the other hand, authorization means proving something about what you're allowed to do. It doesn't care who you are. All it cares about is what permissions you're being given. And again, in Pelican, we're not dealing at all with the who part. We're dealing with the what part. So there are a few things we need to accomplish. We want to respect the autonomy of the object store owners. And that means we first need to provide them with a way to construct policies about what types of things their object store is willing to support. So the first is, what does your object store allow you to do? Can you read to it? Can you write from it or write to it? And secondly, how should the data in your object store be accessed? And who gets to access it? And that's, again, a kind of fuzzy question here. Second, the enforcement of this policy shouldn't require that the object store owner shares secrets with the Federation administrators. If they have to share a secret, that means that all of a sudden they're kind of centralizing all of this authority in one spot. And we want to maintain that autonomy. So we don't want to design a system that requires that. Next, we need to make sure, because Pelican has this caching infrastructure that sits between the origins and the clients, we need to make sure that the policies crafted by these object store owners and applied at the origin are also applied to all of the things inside the federation. And then finally, again, in distributed high throughput computing, we have to do all of this in a way that scales. So why not just use regular passwords? What's the problem here? Well, the first problem is you could imagine a user coming and placing 10,000 jobs. Now, at this point, they have kind of two options that are equally bad. The first is they put their password in plain text on the disk, and they use that to automate authentication with all of these different jobs going out. We don't want people doing that. The second is that they enter their password 10,000 times, which we also don't want them doing. The next problem is that even if we could figure out good ways to deal with throwing passwords out into jobs like this, it's very difficult to distribute the ability to verify passwords. So you could imagine if we needed to distribute some kind of password verification database across all of the caches and origins in a Pelican Federation, that would be a difficult thing to do. And we've seen that with 40 years of Condor, that distributed authentication is a difficult thing to do.
A password doesn't convey who you are.
No. Yeah.
Okay. If you think that if you give me my password, it defines who you are, you will disagree with me. I think the only thing that the password conveys is a potential association with an identifier, right? Your credit card, you have a password. It doesn't say who you are. It says that whatever ID you gave, you are associated with it, or whoever issued it is associated with it. So I think it is important to keep this idea in place. And the other part, I don't know if you're going to touch it, is that the whole question of authorization in Pelican is not only at the origin, it is also at the cache.
Right.
So all these problems have to be, all the information about association between identifier and password has to be distributed across all the caches, not only on your origin.
Right. And I think that's one of the mistakes we make, is that we often treat passwords like they are who you are, but they are not. And so yes, getting back to your point, it's the distribution of this kind of thing of passwords and password management that gets to be infeasible inside of these federations. All right, so what does an access policy look like? If you're at the origin, what do you actually do to convey how your objects are accessed through Pelican? I think this is a great place to put aside the technical stuff and start by writing down in plain English, what do you want to accomplish? So some examples of what someone might want to accomplish are, anyone can read my data, but it costs me 10 cents every time they do. So I'd like to minimize the number of times that anyone comes to talk to my origin. So this might be a case where your data is in AWS, and so you'd really rather that people come through the caching infrastructure that Pelican provides. Another example policy might be, Susan can read and write from my object store through the origin, but John, he only gets to read. So the first step that Pelican needs to accomplish is translating this English into some kind of configuration. And in Pelican, we do that using the kind of monolithic Pelican configuration file. So the important thing to note here is that we have some storage prefix. This is the piece of your object store that you're managing through the origin. And that's tied to some federation prefix. That's that namespace mapping that we do. And then here we have a list of capabilities. We say that for this section of my object store, I'm willing to let people read publicly. I'm willing to let people write to it if they have the appropriate authorization. And I'm willing to let people list. And so this is the kind of language we work with in Pelican. So reads means you can get data with appropriate authorization. Public reads means no authorization. Writes and listings do what you would expect. And direct reads is this one that I mentioned in the previous slide where the origin is saying, I'm okay if people come and talk to me directly. I don't care that you come through this caching infrastructure. So we configure these policies at the origin because the origin is responsible for implementing these policies on behalf of the object store. But we need to find a way to distribute these policies out to all of the Federation caches. So we do this using our director service, which acts as kind of the propagation mechanism of all the information that we have in a Pelican Federation. So the origin sends its policy to the director, and then the caches in the Federation will periodically pull the director and ask for new namespaces and new policies that it needs to be aware of. On the other hand, one cache is also responsible for implementing the policy of multiple origins. So if we have 3 different origins, they're all sending some policy information to the director. This one cache is responsible for learning about all of the policies from these origins and combining them into a kind of master policy. So next, the answering how we kind of handle who and who can do what and when requires discussion of these 2 scary concepts from earlier, tokens and issuers. So what is a token? We've already talked a little bit about tokens, so I won't spend too much time on this slide. A token is a way of saying what you're allowed to do, and to refine my slide with what Mattia said, what you're allowed to do to a specific resource. They don't say who you are. We're not in that business. And there are a few important attributes that tokens carry. The first, again, is that they state explicitly what you're allowed to do. And the second, I think that's worth noting, is they have well-defined lifetimes. So unlike a password, which exists and exists and exists until you change it, a token at its creation time is given well-defined birth and death. So what's an issuer now? Well, an issuer is logically any service that we can use to create and to verify tokens. But in practice, we're computer scientists and we think everything can be solved with another layer of abstraction or indirection. We actually treat these like 2 different things in a lot of cases. And that causes a lot of confusion, both for us and for our users. So it's especially bad if it's causing confusion for us. And so I want to try to distinguish these 2 different things that we call an issuer. The first is the service that you use to get tokens, and the second is the service that you use to verify those tokens. And I'll try to be clear when I'm talking about one versus the other for the rest of the presentation. All right, so I want to go through an analogy because if you're not a computer scientist, this stuff is still kind of probably a little fuzzy to you. So hopefully you've all had a chance to go to a concert or a live performance of some kind since COVID ended. And if you did this and you didn't go through something like Ticketmaster, you might have done the following. First, you get to the venue and you walk up to a ticket kiosk. Now, this is like the get issuer, the thing that provides you with a token. So you put in your credit card, you enter some information, and it spits out a ticket. Now, importantly, this ticket is going to get you into the building, but it also comes with a specific capability. You have the ability to sit in seat 2. Now, one thing to note about this ticket here is it's got some funny, fancy paper that shines and a little barcode and these. So there's some security baked into this ticket. And that's going to be important in a second. Next, there's this concept of the gatekeeper, the person you have to walk by when you want to enter the venue. And in this case, the gatekeeper has a clipboard that references for him what does a valid ticket look like. So he's able to take the ticket you hand him, compare it to his clipboard, double check that the holograms on the tickets look pretty similar, that everything looks like it's authentic. And if your ticket looks good, he lets you into the building. And then finally, you enter the building and you go and you sit in your seat, number 2. So this is, I think, at a really high level, the way token authorization works.
Staying in your concept, what if I said that the token has a seat number and you're allowed to sit only at this location? Would that work? Do I have to do read foo? Do I have to turn it into a computer science example while I can stay in the concept? So is there a difference between going to the issuer and buying an economy class and then trying to sit in business?
Yeah, so maybe you could expand this to cover general admission or something like that. The ticket gives you an area that you can sit in and not a specific
but it can
seat.
give you a seat. I mean, you can read foo is, I would argue, is no different than you can sit in row L, seat 129.
I agree. Yeah.
And we don't have to do foo because normal people will run away when you start reading foo.
All right. So in Pelican, we provide kind of 2 different flavors of how to set up and manage and run this issuer thing. The first is the easier thing to set up, but it's harder to maintain in an ongoing basis. And this is where you, the person who has some stake in the objects that are federated through your object store, you hold on to your own private key. Now, this means that you have to know how to create tokens, which, as we discussed earlier, can be a confusing thing to know how to do. And if you make mistakes, it's even more confusing to figure out what you did wrong. The nice thing about this, though, is again, you get to keep all your secrets. You don't have to share them with anybody. But it also means you're responsible for manually implementing the policy decisions for your origin. At the time of token creation, you're deciding who gets to do what with what data. The second option is to set up a service that's baked into Pelican at this point called OA4MP, stands for OAuth for many people. And we're going to say for now that it magically integrates with some kind of an identity provider. So you can go talk to Jim Basney about how all of this works. He's going to deal with the who. We're going to deal with the once we know who you are, what do you get to do? The nice thing about OA4MP is once you've set everything up and given it some kind of policy, it'll implement that on the behalf of the origin. So it'll decide, once it's figured out who you are, what things does it want to let you do with the tokens it creates. So this is roughly what these 2 different configurations look like in Pelican. On the left, we see this is the Pelican token creation tool that we provide currently, Pelican Origin Token Create. You have to enter all of this metadata. If you make any typos or you don't know which fields are correct, or we as the Federation administrators set something up incorrectly, this isn't going to work for you. So there's a bit of a minefield that we lay here with that. On the right side, this is a piece of the total OA4MP configuration. And I think the keys to point out are that we define some prefix, some part of the federation. We define some set of users, and then the set of actions that those users are allowed to take for that resource. All right, so I want to go through an end-to-end example of kind of what this looks like in Pelican.
That's what the users assume a namespace. So what is the namespace of users of the issuer? What is this funny thing, Jay? Something at mortgage.org. I mean, what is it?
So there's, I
You,
think
you assume that an email means anything?
there is a magic integration with something that touches on the identity concept. And that magical integration that I didn't want to talk about today is the thing that defines the namespace of who using identifiers.
But these are the identifier. It can be X7798.
Right.
So somebody has to manage a namespace for identifiers because you say it's a user. No, it's not a user. It's a random string in some namespace,
All right.
right?
Taken.
Because it can be Googled, it can be my favorite dog at google.com.
So
Is that user? Is my dog a user?
something that we associate some bit of metadata, a string or an email, with what we would call a user. So in this case, nobody else on campus has my email. It's associated only with me.
I don't know. Maybe.
I hope not. All right. So end to end, this is what this looks like. The first step is for the origin to construct its configuration. It defines, what types of things is my origin willing to support, and it bundles this policy and sends it off to the director. Now, this arrow that I have here is kind of incorrect because the director doesn't push this policy down to the cache. Rather, the cache is polling the director and asking for new policies that it needs to implement. So the cache becomes aware of foo. It knows that foo is tied to foo issuer, and it stores a copy of that policy locally. So that's the setup. Next, there's again this magical integration with the who question. So this client goes off and it says, I am some client. And once we've agreed that you are who you say you are, we're going to decide, the issuer is going to decide, what tokens am I willing to grant? So the issuer says, okay, you get a token to read foo. At this point, the client sends the token to the cache. The cache has the responsibility of going and grabbing that clipboard from the verify issuer, checking the token it was handed and making sure they look like they match, everything checks out. It puts that clipboard down and it says, well, unfortunately, I don't have what you're asking for. So it forwards that token to the origin that it thinks will be able to deliver the object you're asking for. And the origin goes through the same process. It goes to this verify issuer, pulls down the clipboard, compares the two, double checks that your token looks good, and it decides that it likes it. So at this point, the origin does something a little different. It puts that token to read foo down, and it picks up some other kind of authorization or authentication protocol. And the reason we make that break there is that we can't assume that the object stores we're working with will speak the same kind of authorization that we speak. So the origin implements some object store specific protocol to authenticate or authorize with that. And it picks up that kind of protocol and uses it to get the object out of the object store. If all of that checks out, the object is sent back to the cache makes a copy, and then finally the object is sent back to the client, and hopefully our users are happy. So this is a complicated procedure. It's confusing to people who aren't computer scientists, and we're continually trying to think of ways to make things just a little bit easier for people. So we have a new tool coming in Pelican 7.17. Instead of Pelican origin token create, it's going to be Pelican token create. So we've stripped out one word. And I think the thing that's important to note about this is that because the director knows about all of this configuration and this policy and all of these different pieces of what goes into creating a token, we can just tell you what to put in the token. We don't require anymore that you know all of these audiences and profiles and scopes and all of that kind of stuff. The other nice feature about this new tool is that if you have a key and that key doesn't check out with what we think your key needs to look like, we're able to tell you, you're creating a token, but it's probably not going to work, so you should talk to someone about how to fix it. All right, and I think that is the end of things. So.
first of all, great talk, and I appreciate that you opened by expressing respect for the user, because I think that's a challenge in what we do. Could you go back to your graph with the just two-step? Yeah, right there. Yeah. So I think a thing that we struggle with in understanding trust in all these systems is to figure out the meaning of delegation. And I think there's many different ways to do it, and it's never quite clear which way to go, right? So forgive me for changing the metaphor. If I go to a restaurant and order the lobster, okay, right? And I talk to the waiter talks to the chef talks to the buyer goes down to the dock and says, I need a lobster. Well, who's buying the lobster? Is it me? Right? Or is it the restaurant buying the lobster? Right? So, when do we pass through I almost said the bad word. When do we pass through the idea that the original buyer is doing this thing all the way through the chain versus I asked the waiter to do something and now the waiter on his own authority does that thing, right? Because I could argue in this case, the client should present valid credentials to the cache. And between the cache and the origin doesn't care who's requesting it. They only care that the cache is trusted, because origin has to trust the cache anyway, because the cache could just give it to anybody after that. So I'm not sure what the answer is, but do you have any thoughts on when you push all the way through the system versus when do you do a handoff of authorization? Ooh, I said a bad word again. Yeah, all right.
Oh, you said authorization. That's okay. Yeah, so I think one of the things that this system is designed around is the client need not go through a cache necessarily to talk to the origin, regardless of whether or not the client, okay, not in every case. In some cases, we do make that requirement. So we want that piece, that handoff of authorization from client to origin directly to feel a lot like it does from cache to origin. And so maybe that's where part of that pass-through of tokens comes from. But I also think, too, in your case of the restaurant, you're asking the waiter to procure some lobster for you, and you're trusting that they are going to pass this along the chain of command at the restaurant to make that lobster happen. And so,
but Doug, I don't think that your lobster. Turn it around. I am running the kitchen, and I'm saying I don't want to serve lobster to Doug Thane. Last time I served him a lobster, he complained and he didn't like it. So no lobster to Doug Thane. Now I have you ordered from the servant. They come to you and say, give me a lobster. Now, do you tell the servant not to take an order for a lobster from Doug Thane? Or do you say, hey, every time you show up and ask for a lobster, because even in this model, and that's personally where I want to go, is the object store is delegating to the origin the authorization, because the object store doesn't have an authorization. It doesn't know who Doug Thane is in the object store itself, but it wants OSDF. It wants the server in this case the cache, not to serve to Doug the lobster. So the question is, does the origin or the cache knows who is who carries the identifier of it's now a trust question. A trust question is, do you trust the origin to prevent unauthorized access to your data? Because the origin may have access to all the data.
So Doug, maybe the thing I'd add, and I like your analogy. I mentioned a bit in the morning, is we've been thinking about this question, and to some extent, maybe this is the computer scientist me, is we decide to do both. That the current version, the origin can say, I want proof that you have an order from a real person. I want proof that you have a Doug Thane out there. Somebody asked for the lobster. And I want proof that you're a real buyer. So we decided that we wanted to be able to show that there is a client out there that the issuer has provided a capability to, and we wanted the cache to be able to identify itself as a real cache and not just some Yahoo from Russia. So maybe it's the human in me that decided to go all of the above, but yeah, this is one of the trade-offs we've been thinking of.
All right, let's thank Justin again.